Have you ever wondered how the flow of a river can teach us about fluid dynamics? Picture this. A river meandering through a canyon, its path widening and narrowing. This is a living illustration of fluid dynamics in action. It's steered by a key principle, the conservation of mass. Simply put, the water that flows into one section of the river must flow out of another, unless we're in a magical realm where water can disappear or appear out of nowhere. Now consider incompressible fluids like water moving at a constant speed. Here, the product of the river's cross-sectional area and the water's velocity stays the same. This means that the river's flow changes as it snakes through the canyon. So when the canyon narrows, the water rushes faster. If it widens, the flow slows down. That's fluid dynamics at work. But what happens if our fluid can compress, like air? Well, the game changes quite a bit. You see, when we're dealing with compressible fluids like air, the density of the fluid becomes a key player. Imagine that river of air flowing through our canyon. As it enters a wider section, it doesn't simply slow down. More happens behind the scenes. The density of the air changes as well. In the world of fluid dynamics, this is a significant shift. To account for this change, we don't just sit back and watch, we take action. We adjust our equation to include this varying density. Yes, the equation that once only considered the area of the cross-section and the velocity of the flow now has another variable in the mix, density. So in the case of a compressible fluid, it's not just about the area and velocity. Density plays a crucial role too. Why should we care about fluid dynamics and the conservation of mass? Well, these aren't just abstract concepts confined to textbooks. They're at work everywhere around us, playing pivotal roles in the way our world functions. Take, for instance, an airplane wing. The air flowing over it is governed by these very principles of fluid dynamics. The shape of the wing or airfoil is designed to manage this flow and generate lift, allowing the plane to defy gravity and soar into the skies. Or consider a car's engine. The exhaust gases expelled are also subject to these principles. Engineers, by understanding and applying the conservation of mass, design exhaust systems to efficiently manage this flow, ensuring your vehicle runs smoothly and efficiently. So, whether in the sky or on the road, fluid dynamics and the conservation of mass ensure optimal performance. Remember, a river's flow can teach us more than just the beauty of nature. It can unravel the intricate science of fluid dynamics.